How can drought intensity be accurately predicted? Imagine trying to forecast a storm before it forms or predicting how dry a landscape will get months in advance. That's what water managers aim to do when they try to predict drought intensity. It's a complex task that involves many different tools and data sources working together. To get it right, experts look at rainfall deficits, soil moisture levels, vegetation health, and groundwater storage. These indicators give clues about how severe a drought might become. Scientists use drought indices to measure conditions over different time frames. The Standardized Precipitation Index looks at rainfall anomalies, showing how much less rain fell compared to normal. The Palmer Drought Severity Index combines temperature, soil moisture, and rainfall to give a broader picture of drought severity. These indices help compare droughts across regions and time periods easily. Remote sensing technology adds another layer of information. Satellites can monitor soil moisture, vegetation health, and groundwater levels in real time. This data helps identify early signs of drought that might not be visible on the ground. Combining satellite data with measurements from weather stations and stream gauges makes predictions more accurate across large areas. Advanced models also play a big role. Probabilistic forecasting uses historical climate data, current observations, and climate forecasts to estimate the chances of drought happening and how intense it might be. Techniques like Bayesian statistics, machine learning, and data assimilation help manage uncertainties and improve forecast accuracy. Using multiple climate models together, called multi-model ensembles, balances out their individual strengths and weaknesses, giving a clearer picture. Climate prediction tools, such as those from the International Research Institute, provide forecasts of drought indices over periods like 3, 6, 9, or 12 months. These help water managers plan ahead for possible drought conditions. Early warning systems use special indices to detect rapid onset droughts, sometimes called flash droughts, which can develop in just a few weeks. These systems alert communities and water agencies early enough to take action. In practice, predicting drought intensity helps in adjusting reservoir releases, planning irrigation, and managing water supplies. It guides the development of drought contingency plans and emergency responses. It also helps identify where more monitoring stations are needed and supports ecosystem management by predicting stress on plants and animals. All these methods come together to give a clear, timely picture of how severe a drought might become. Combining climate data, remote sensing, statistical models, and real-time monitoring allows water managers to prepare better and respond more effectively. This integrated approach makes it possible to predict droughts with greater confidence, helping communities stay resilient in the face of dry spells.